Okay, finally, we are going to see like kind of the exercises that are the most complex or the most difficult ones in that we are going to see in this semester. And basically they are the same, okay? Don't worry. They are the same as the previous truth table that we were seeing in this video, okay? Don't worry. The unique difference is that we are going to make the truth table from a given argument written in natural language. That's the point, and that's the problem, you know. Given this argument, this syllogism, that actually this is a disjunctive syllogism, or the dilemma that we're going to see one example of the dilemma. Given that example, or this syllogism written, that's the point, that is written in natural language. Our duty or our task is to change that or change this into the symbolic language, and then write the expression of the truth table, and then make the truth table and state if that is tautology, contradiction, or contingent, you know. So it's the same thing, but trying to, or symbolizing from the natural language this argument, okay? That's the whole point, okay? Now, I'm going to give you the steps for that, okay? Or the tips, because I mean, you can do this in maybe several ways, but I'll give you the ones that for me are like the precise and the concise ones, you know? So, in this one, please notice that we have a disjunction, we have a disjunctive syllogism, okay? How do we know that? Because we have the words either and the words or in the first premise. As you can see, if we analyze this, you will see that this is a disjunctive syllogism, as I already said. And if I draw a line here, you will see that these both are premises and this is the conclusion. How can we know that this is a conclusion? Because we have the word therefore, you know, as simple as that. So, in any argument, and you know this, the main purpose of logic is to reach new conclusions, but the way, or the way that we can reach those conclusions are always from the premises. Without these premises, we cannot be able to conclude this, okay? Now, in this sense, please notice that in the first premise, that this will be like the major premise, we have an exclusive disjunction, okay? The words that I highlight in red, I don't highlight, but okay, either and or, this denotes a exclusive disjunction, okay? Remember, and if you don't remember, in the last working guide, I gave you how do we read the logical connectives in natural language. The natural language for the exclusive disjunction is with the words either and or, okay? In the second premise, I'm not going to the movies, we can see that we have a negation, okay? So either I go to the movies or I go to the party rock. So given this premise, then I say I'm not going to the movies. So if I'm not going to the movies, the point of the exclusive disjunction is that cancelled one of the members, you are going to go with the remaining one. If you deny this, you are going to affirm this one. That is logical, okay? So either I go to the movies or I go to the party rock. I'm not going to the movies, therefore I'm going to the party rock. And that is the point of as I am saying, the exclusive disjunction, okay? That is quite easy. And the point is, and here is the recommendation. The step number one, always the step number one is the variable declaration, okay? We need to declare the variables. So, how can we know that? Remember that any single variable has, that could be A, B, C, blah, blah, has the structure of the subject term plus the verb plus the predicate term, okay? So if we analyze, for example, this first premise, either I go to the movies or I go to the party rock, we see that we have actually two variables. This is the first one, and I'm going to write in another color the second one. Or I go to the party rock is the second one. And as you will see, for example, I go to the movie, this is the first variable that is linked with this other variable or this other statement. Remember that the variables represent statements, and the statements have the structure of the subject term, the verb, and the predicate term. Statements. Okay? So I have one statement here and two statements, and the second statement here linked by a exclusive disjunction in the same premise. In this one, I'm writing one of these statements, one of these variables, but in a negative way. And finally, I'm writing the same statement of the second member of the exclusive disjunction here in the conclusion. Is the conclusion that I'm getting from the relationship between this premise and this premise. So what is the first thing that we need to declare? Well, the variables. So the variables, let's say that this is A. I go to the movies, it's going to be A. And let's say that I go to the party rock, let's say that this is P. I'm going to say that this is M because of the word movies, okay? So this is movies and this is party rock. So A is equal to I go to the movies and P is equal to I go to the party rock. Now, one question, do we need to declare a new variable for this statement? I'm not going to the movies. So imagine that, let's say that this is, I don't know, age. I don't know, random variable. Is that correct or not? If I say age is, I'm not going to the movies. Now, please notice that A and H are actually the same statement. What is the difference? That this is a negation, this is a negative, okay? And remember that for the last week, or in the last week, I told you, like effortlessly, that we never declare a negation in the variable declaration. Why? Because the negation itself is a logical connective. That is really important. The negation itself is a logical connective, and if you declare a statement as a negation, you will affect actually the truth table. That's the reason. Okay? So this is wrong. So H is not actually a variable. It's the same variable P that we already have here. Okay? Now, once we already have the variables, now we can symbolize each premise and the conclusion. So if we do that, for example, in the first one, either I go to the movies or I go to the party rock. For the first one, I have the variable or the symbol for this statement. I go to the movies is represented by the variable M. And I go to the party rock is represented by the variable P. Now, what is the logical connective that is linking to these two variables? That's right, the exclusive disjunction. And the symbol for the exclusive disjunction is this one. Okay? That one. Now, I'm not going to the movies. I'm going to write like this. I'm not going to the movies. Going to the movies or go to the movies is represented by the word A. Sorry, a little mistake here. I declare from the beginning this as M. I'm really sorry. This is M. Okay? Now, I'm not going to the movies. This is represented by the variable M. Okay? And now, as I already told you, we don't need to declare again the same variable but in a negative way. Why? Because this is the reason. because we are going to write the negation here. Okay, we must write the negation when we symbolize the variable. The negation never goes in the declaration of the variable. The negation only goes with the proper symbolization of it. Okay, and finally, therefore, I'm going to the party rock. Therefore, P. As simple as that. What is the symbol for going to the party rock? P. As simple as that. Now, this is the tricky stuff. That is not kind of tricky, but it's like, I don't know, it's like the thing that can become kind of difficult in this way of solving a truth table. We have this symbolization or this expression for the first premise. We have the negation of M for the second premise, and we have P for the conclusion. Now, we have, or we know already that we have a therefore here. So this therefore is in this sense kind of a conditional that in which the antecedent is this. Wait a moment, okay? So how can we transform or change these three expressions into one single expression in which we can construct and build the truth table? Okay, when we unite two premises that are these two ones, what is the logical connective that links, that merges, that unites the propositions? The conjunction. Yes, we need to use a conjunction if we want to link these premises. Actually, because of this link, because of this relationship between these two premises, we can conclude this. This is related to this, or in other words, this premise has only sense if we already have this previous one. For example, either I go to the movies or I go to the party rock. If we don't see this one, and if I only say I'm not going to the movies, I cannot be sure how the hell I concluded this, right? Now, in other words, always when you linked the first premise and the second premise, or any single premise, that imagine that you can have two or more premises, you are going to link them through a conjunction. Always you are going to link them through a conjunction, always. And to the conclusion, we are not going to link these premises to the conclusion with a conjunction, because this is like kind of the result of the inference from the relationship that is represented by this conjunction of these two premises. So in that sense, the logical connective that is going to represent any conclusion that gives us the new information is the therefore, but in that sense is the conditional, is the consequent. Okay, these both are the antecedent, and this one is going to be the consequent. Okay, to conclude something is to know the consequence of something. Okay, so in this sense, you are, in other words, and write this down, this is really important. When you link premises, it could be two or more premises, you are going to link them through a conjunction. And the final logical connective that is going to give us the information that this is the consequent or the consequence of the previous information is going to be the conditional. Always. That is like a logical structure, okay? So in this sense, if we do this, the final expression is going to be M exclusive disjunction P, exclusive disjunction P, conjunction. I can protect myself with a parenthesis. Is that okay if I write a parenthesis in this expression? Yes, and actually I recommend you that you do that, because this parenthesis is expressing that this is a whole expression. Okay, this is the same expression. M exclusive disjunction P is the same expression, and I recommend you that you write down those with a parenthesis. Okay, because it's the same expression. You are stating the very same expression. So exclusive disjunction P, conjunction, negation of M, yes, conditional P. And this is our last expression in which we are going to, or that which we are going to use for the construction of our truth table. Okay, I'm going to make quickly the truth table of that expression. Then you can see that. Okay. Sorry. Before doing the truth table, I want to say something about the punctuation. I said that we can use the parentheses here. Now, is that okay? For example, if I write brackets here, yes, that is okay. Why? Because these brackets represent what is linking, or what is linked in the premises, and what we are saying, logically speaking, is that this whole expression, or the expression that is contained in the two previous premises, is going to give us this new conclusion. Okay? Therefore, or then, we are concluding P. But these brackets represents the relationship by the conjunction of these two premises. So, okay, so is that okay if we wrote the brackets? Yes, there is no problem, and actually I recommend you to do that. Okay, so we're going to solve really quickly this first example about the arguments symbolized from the natural language and then constructed in the truth table. So this was the previous expression, and I'm going to solve really quickly, or we're going to solve this really quickly for the truth tables. Okay, so the first step, remember that we are going to write to the left of the expression the variable that compose the expression in the order that they appear in the same expression. So M appears first, and then P appears, and we have repeated M and P. So the first the first variable that appears is M, and the second variable that appears is P. Okay, so we don't have a third variable, so we are going to build the truth table with those variables. Okay. Now the next step is to determine the number of lines that we are going to have for the truth table. So we have 2 to the power n, or 2 to the n power, and remember that n represents the number of variables that we have in the expression. So in this sense we have 2 squared, and this is 4. Okay, so we are going to write 1, 2, 3, 4 lines that for our truth table. Okay, now we are going to determine the values of truth and or falsehood in the variable combination area, and we are going to start, remember, from the column of the right. Imagine that we are not saying this part. We are going to start for the column of the right, and we are going to move forward to the left. So we have only 2 variables, so we have P and M, and we are going to start writing and alternating true and false in the first one, true until we finish, true and false, and then 2 times true and 2 times false. Okay, and that's all. And finally, we are going to, well, not finally, we are going to write or determine, this is, remember, again, the most important step to determine the level of dominance of the logical connectives. We have an exclusive disjunction, a conjunction, a negation, and a conditional. So 1, 2, 3, 4. 4 logical connectives. As you can see, I'm going kind of faster because I don't know. I suppose that you saw the previous exercises. Okay, so as we can see, the first logical connective, or the primary logical connective, or the most dominant logical connective is the conditional. Okay, I'm going to designate that by the number 1. Then the second one, as you can see, this conditional links this expression contained into the brackets with this expression, with this variable P. Remember, and we can see, actually, this is the point, we can see how logic works. Okay, this symbol is telling us that this is the conclusion, or this is the knowledge we obtained, that we got from this, okay? The antecedent and the consequent. That's the reason for the conclusions we always use this this conditional, okay? This is the conclusion, or if this happens, it's going to happen this. That is like what the logical language is telling us, you know? So we are going to take this expression into the brackets as the antecedent and P as the consequent, okay? In this expression into the brackets, we can see that this conjunction is, as I told you, remember that this was the major premise, that is like the exclusive disjunction, and this was the minor premise. What we are seeing that this conjunction is linking the major premise with the minor premise. It's the same. We are seeing actually, this is really beautiful. We are seeing how logic works, okay? How logic, and this happens actually with math as well, is kind of a translation for the natural language to different types of understanding. I wouldn't say that it's better or not, I don't know. But, I mean, this is like the mechanism of logic, you know? So, we see the conjunction that links the major premise, or the expression of the major premise, with the expression of the minor premise. So the conjunction is going to be the second one, because we cannot solve this conjunction without solving first or previously this exclusive disjunction and this negation. So in the third level, or in the third step, is going to be the exclusive disjunction and the negation. As you can see, the premises, sorry, this is 3. The premises are in the final step. We need to solve the premises, then we are going to solve the conjunction that links both of them, and then we can solve the conditional. So the exclusive disjunction and the negation are going to be the 3. Okay. So now we can separate these in columns. Okay. We can separate, for example, this one and this one with this one. Remember that in this case with P, I'm going to take these given values of P. I don't want to write another time the values of P here, because I'm really huevón. So if you want to make a column here or write a column here and rewrite again these values, you can do that, okay? So for 3, we are going to solve the number 3. Remember that the rule of the exclusive disjunction is that this is true when the values of the components of the exclusive disjunction are different, okay? If the values of M and P are different, this exclusive disjunction is going to be true, okay? Actually, this is kind of the first exclusive disjunction that we solved. So true and true are the same values for M and P, so this is going to be false. Remember, the exclusive disjunction is going to be true if if both of its components have different values, okay? True and false, this is different. So true, false and true, true, and false and false, false, because these are the same values, okay? M and P have the same values here, so again, the exclusive disjunction always true when the values of M and P, or the components of the exclusive disjunction, are different, okay? Now, the negation of M is really simple. This is false, this is false, this is true, this is true. Okay? And now we can solve this conjunction. This conjunction considers, or is going to be solved considering these two trees. Okay? So remember that the conjunction says that this is always, the conjunction is true when both components, in this case, this number 3, that is the exclusive disjunction and the negation of M, are both true. Yes? If both are true, the conjunction are going to be true. So we have false and false, this is false. True and false, false. True and true, true. False and true, false. And finally, we are going to write number 1. And for the number 1, we are going to consider 2 as the antecedent. In other words, 2 represents the result of linking the two premises that give us the new information that is the conclusion. So this is the antecedent, and the conclusion is always the consequent. Always consequent. Always, always, always. So we have given already this conjunction that we solved previously considering 3 and shalala, and we have P given here. So remember, the rule of the conditional is always true except when the antecedent is true. We need to keep our eyes here, and the consequent is false. So if this is true and the consequent is false, that P is here, this is going to be false. So false and true, this is true. False and false, this is true. Eyes on here. This is true. Again, the conditional is always true, except when the antecedent, number 2, is true and the consequent P is false. But in this case, we have true and true. So this is still true. And finally, false and false is going to be true for the conditional. So this is our last column. This is our result, and we say that this is a tautology. Ka-ching! I don't know what that means, but yes, tautology. Okay? And finally, our last example, okay? I'm really sorry for all the large videos, because I'm thinking that it's going to be separate videos, but this is the last example. And if we had in the previous example the disjunctive syllogism, in this case we're going to have, as you can see, a closed dilemma. Okay, remember that the closed dilemma is when we have in the major premise or in the first premise a disjunction. We have the either or an or, and that is the exclusive disjunction. We will have again a exclusive disjunction, and then we have two premises that are two conditionals. If you get married, then you will regret. If you live in consensual union, then you will regret. Here, the then is kind of understood, okay? If the word then doesn't appear here, don't worry. I mean, it's kind of known that it's implicit there, you know? And finally, if you get married, you will regret. And if you live in consensual union, well, consensual union is unión libre. I don't know. I mean, this is kind of a silly example, you know? But I support any kind of love, you know? Obviously. And finally, therefore, you will regret, okay? Either you get married or either you live in consensual union, you will regret. Finally, therefore, you will regret. That is the conclusion, okay? Remember that this was called a closed dilemma because we reach a single the same conclusion, okay? Remember that in the open dilemma we would have another exclusive disjunction because we have like two possibilities or two options. In this occasion we have a closed dilemma since we have only one option left, or the premises leave us with only one option, that is that we are going to regret. Either we get married or live in consensual union. So we are going to declare a variable declaration. The first step is to declare the variables, okay? So let's analyze the first one. Either you get married or you live in consensual union. So here we have either and or, and we have an exclusive disjunction, okay? Therefore, this exclusive disjunction is linking two statements, get married and consensual union. I'm going to say that getting married is M, married, and consensual union is, I don't know, C, okay? So you get married or you live in consensual union, okay? And this is a exclusive disjunction, okay? Easy. Now we have a conditional. We have the conditional. Here is the word then implicit. The same here. The word then is implicit here. And we have the conditional and the word then, okay? Or then this will happen. This is the antecedent. This is the antecedent of the conditionals, and these ones are the consequent. The consequent is that it doesn't matter which case we are talking about, in both cases we are going to regret, okay? So the consequent is the same, and actually that is the closed dilemma. you got as the conclusion and the consequence of the conditional of the middle premises, okay? So in that sense, we know that this conditional, remember that, is symbolized only with an arrow but in the middle. In the place of this implicit then, we are going to put the arrow, okay? We don't put the arrow here. If you put the arrow a double time, that is wrong, okay? We never put the arrow there. So I'm going to erase these arrows. And then this conditional is leaking the you get married is M, and we haven't declared yet this you will regret. Let's say that we will regret is R, okay? So we see that consensual union is C here, C, and then we will regret R, and in conclusion we have R. So in the variable declaration, well, I already symbolized each one of the premises and the conclusion, but our first step was or should be saying that M is equal to you get married, okay. C is you live in consensual union, and finally R, you will regret. Okay? So we have this variable declaration, and as you can see, these three are the premises, and this one is the conclusion because of the word therefore, okay? So we are going to symbolize each one of the premises and the conclusion, and then we are going to link and unite them in a single expression in which we are going to build and construct and make the truth table, okay? So that is kind of something that we can do, okay? For example, either you get married or you live in consensual union. Actually, all the symbolizations are already given, or I already, not given, I already symbolized them. So we have M, either you get married. This exclusive disjunction is the same as the conditional in the sense that you don't need to write again the symbol of the exclusive disjunction here. This is wrong. You only write the symbol of the exclusive disjunction in the place of the or. Okay, so we have M exclusive disjunction C. Okay, then we have M conditional R. Let's say M conditional R. Okay, and then we have C conditional R. And then finally we have as a conclusion R. Okay, so as I explained in the previous video, we are going to this conclusion R, you will regret, is only possible with the conjunction with the if we establish a relationship between these premises. Okay, we start with this premise and we are going to unite this with this one, and then we are going to unite this with this one, and the union all of these premises are going to give us this conclusion. Remember that the logical connective that by excellence unites, conjuncts, that is kind of redundant, but the logical connective that by excellence make a relationship or establish a relationship between two variables or two statements, or variables and statements, as you can see, is the same. That logical connective is the conjunction, and here again is the conjunction. We are establishing a conjunction with this one and this one and this one and this one, and all of these relationships, I mean, all of these this kind of relationship is going to give us the conclusion that is you will regret with a conditional. Okay, now we have, if this happens, then this happens. That's the logic hidden there. If this happens, if the relationship between the major premise and the middle premises happens, then R is going to occur. This is the antecedent. It's like we have this is the antecedent. Again, este es el antecedent, and here is the consequent that is only R. And finally, the expression that we are going to use for the truth table is M exclusive disjunction C. We can remember that we can protect the expression with a parenthesis. Conjunction, yes, M conditional R. Remember that we can protect the single expression because we are symbolizing the single expression with, and we can put that into the parenthesis. Conjunction parenthesis C conditional R parenthesis, and as I told you in the previous example, imagine that since this happens because of the relationship of this one, we can make a bracket here and a bracket here that is telling us that this is a relationship together, that this is like a single expression, that because of that expression, this whole expression, we are going to obtain this one. That's the reason we can put here some brackets and we protect ourselves finally, and finally we write the conditional R. So we are going to build our truth table using this expression. Okay, finally the last examples. Okay, we are going to solve the expression that we got from the symbolization of the previous clause dilemma. Okay, the dilemma about getting married or living in consensual union, you know. Now, remember, our first step is always writing to the left of the expression the variable that compose this expression. As we can see, we have MC and R. Okay, MC, R. We have three variables, and we are going to write them in the order they appear in the expression. As we can see, M appears first, then C, and finally R. So we have M. I think I need more space. M, C, R. Okay, and I'm going to write an introductory line here, and then the following step is to determine the number of lines that we need for our truth table. So remember that we're going to do that through this formula 2 to the n power, in which n is the number of the quantity of variables. As we can see, we have 1, 2, 3 variables, M, C, R. So this is equal to 2 to the third power, that is equal to 8. So we will have 8 lines. So we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, and we already can separate the variable columns, or the columns of the variable combination zone. Okay, now our next step is to determine the values of the variable combination zone that we have MCR. Remember that in this zone we always begin, imagine that we are not seeing this part of the expression, or we are not seeing actually the expression, we are only seeing the variable combination zone, and we are going to start from the first column of the right, and we are going to move forward to the left. So we start with the first one, that is R. We are going to change, or we are going to introduce the values of true and false, and we are going to alternate them until we finish the table. So we have true, false, true, false, true, false, true, false. Okay, then we keep going to the left of the or the following columns to the left in the variable combination zone, and we have C. Now if we alternate this one time, we are going to make 2 times and 2 times, 2 times true, 2 times false, 2 times true, 2 times false. So we have true, true, false, false, true, true, false, false. So if we have 2 times true and 2 times false, false in the following and final column to the left, that is M, we're going to write 4 times true and 4 times false. Okay? Now, then this is the problem, and we have an issue here. Actually, this was a kind of another example that I wanted to work with you that is kind of tricky, you know? We are going to determine the level or the grade of dominance of the logical connectives, okay? So, we can see that, as you can see, the most important logical connective in this exercise, as in the previous one, is the conditional, okay? Because the conditional is the one that is unifying the previous expression of actually we have one premise, the second premise, and the third premise. This conditional is unifying all the premises and the conclusion. This symbol is indicating that we got R because of this, okay? So therefore, our most important, in a logical way, the most important or the most dominant logical connective is going to be this one, the conditional. So we're going to write this as 1, okay? And also because these brackets and the use of parentheses of the brackets helps to understand and to see better and faster that this is the primary logical connective that is linking all of this. All of this is the antecedent and R is the consequent, okay? Now, we need to analyze this part. And actually we have one tricky problem or one tricky stuff there, you know? As you can see, we have M exclusive disjunction C all unified or linked to M conditional R by a conjunction. M conditional R is linked with C conditional R with a conjunction. Now, what is the problem here? As you can see, conjunction and conjunction, we have, okay, before that, in this expression, which one is the secondary logical connective? So we cannot solve this conjunction if we haven't solved yet this exclusive disjunction between M and C, and we cannot solve again this conjunction if we haven't solved yet M conditional R. Therefore, this logical connective is more important or is more dominant than these ones. The same happens here. This conjunction links this expression and links this expression, and in order to solve this conjunction we need to solve this first and then this one. But the problem is that we can say that this is 2 and this is 2. The stuff or the problem there is that, as you remember, the conjunction has the very same level of dominance, okay? This is 2 and this is 2. Imagine that we have here, for example, a conditional. If we have a conditional, now the one that is 2 is the conditional and the conjunction will be 3. And that is because the hierarchy of the logical connective, because of the hierarchy of the logical connectives. So the problem is that at the end we are going to have this conjunction, because we have a conjunction here, we are going to have this conjunction as number 2, both of them, okay? And the question that we can try to propose is which one we are going to solve at last, you know, because we have 2 and we are going to compare those to the number 1. Which one is going to be the antecedent? I'm going to say that in a moment, or I'm going to say that straight away. It doesn't matter, okay, actually, but we're going to see that in a moment. And finally, the following or the remaining logical or the remaining grade of dominance will be 3. That would be this expression, and this expression, and those are actually in the same level because of the parentheses, okay? This number 2 is linking this parenthesis and this parenthesis, this number 2 is linking this parenthesis and this parenthesis. So, we are going to name this as 3, 3, and 3. Okay? Really easy. Now, here is the stuff. We already made like the most important job. So we're going to separate this in columns, okay? And finally, this in columns, okay? Now, the problem here is that, okay, first step, can we solve immediately number 3, and number 3? Yes, we can, and that is actually the reason that those are the number 3, because we have MCR and we have exclusive disjunction C, M conditional R, and C conditional R. In this sense, 3, 3, and 3 can be solved immediately, considering that we already gave some values for those variables in the variable combination zone there. Yes, and these ones are the least dominant grade, the third grade in this occasion. So why don't we solve them as we can do? Remember that the rule for the exclusive disjunction is that the exclusive disjunction is true when both components, or in this case M and C, have different values. When M and C have different values, the exclusive disjunction is going to be true. So we have M and C, so we have here false. We have true and true. We have true and true, they are the same value, this is false. True and false, true. True and false, true. False and true, true. False and true, true. Okay? False and false, false, and false and false, false. Why? Because in these occasions we have the same values, and in these occasions we have the same values. In the middle place, or in the middle part in the column, we have the combinations in which we have different values between M and C. Okay? Now we are going to solve M conditional R. In M conditional R, here is the point. Remember that the antecedent for this conditional is M, and the consequence for this conditional is R. Do we have already given values for M and R? Yes, we have. We have that column and we have this column. So we can solve it immediately, yes. Remember that the rule of the conditional is always true, except when the antecedent, that in this case is M, is true, and the consequent, that is in this case is R, is false, okay? So we are going to compare M and R for this number 3. So if this part, the antecedent, is true, the consequent is going to, and the consequent false, this conditional is going to be false. We can see that in this case, that is not the case, so this is true. True and false, antecedent true, consequent false, so here we have a false value. True and true, true. True and false, we have again false. False and true, true. And false, false, false. Immediately we know that they are going to be true because this the antecedent is false. Okay. And okay, we have two values of false. Yes, yes. And finally, the same dynamic, but considering instead of M, we're going to considering the relationship by a conditional with C, with R. Okay, C conditional R. So C is the antecedent and R is the consequent. So the antecedent C, consequent R. True and true. This is going to be true. True and false, false. False and true, true. False and false, true. True and true, true. True and false, false. False and true, true. And false and false, true. So in these two occasions, false and false, were the occasions in which C was true and R was false. Let's see again. C was true and R was false, yes. And C is true and R is false, yes, this is false, okay? Now, so far so good, I hope so. Now the problem, guys, the problem is, or the question is, which conjunction are we going to solve first, you know? So as you can see, with this conjunction links this number 3 with this number 3, okay? These columns, okay? And we can say at first sight that this number 2 links this column with this column, this number 3 with this number 3. The question is, which one do we solve first? This one or this one? Okay, as I told you, that is indifferent, okay? We are going to get the same result even if we solve this first or even if we solve this first. It doesn't matter, okay? But be really careful with a little detail, okay? We are going to write, when we get this primary logical connective, I'm going to write the solution here, or you can, I don't know, take a screenshot or something like that in order to compare the two different ways. Imagine that I'm going to solve first this one, and I'm going to erase and I'm going to rewrite the table, considering in the next case that we are going to solve first this one. But in this case, I'm going to solve first this one. So you can see that it doesn't matter, okay? So if I solve number 2, I'm going to compare this column of 3 and this column of 3. So remember that the conjunction says that the conjunction is true if the both components of the conjunction are true. So false and true, this is false, false and false, false, true and true, true, true and false, false, true and true, true, true and true, true, false and true, false, and false and true, false. Okay? And here is the point. This is really important, ¿eh? This is really important. Lo voy a decir así rápido. Cuando ya resolvieron esta, es como si ya hubieran quemado un cartucho. Ya quemaron el cartucho de esta y el cartucho de esta. Por lo tanto, cuando resuelvan esta conjunción, ojo, uno pensaría inmediatamente, pues la resuelvo a fuerzas con esta columna y con esta columna. Pero ojo, recuerden los cartuchos. Si ya resolviste primero esta, no puedes volver a usar esta, ya quemaste ese cartucho, ¿ok? Puesto que estos tienen el nivel grado de dominancia o el mismo nivel de dominancia, vas a comparar, o vamos a comparar esta número 3 que no lo hemos usado, es un cartucho que no hemos usado, con esta número 2, ¿ok? Estos cartuchos ya se la pelaron, ya no los puedo usar, ¿ok? Ya me la pelé con esos. Pero con este no. Tengo que usar, esta conjunción va a ser considerando este de aquí, and I'm going to change that, my lovely, okay, no, it's not lovely, I know that my pronunciation sucks, but be, I don't know, be gentle with me, okay? Okay, and we are going to consider this, and I'm going to consider this, okay? So remember, if we already used, or if we already used this column, we cannot use it again, okay? So this conjunction, considering this and considering this, so false and true, the conjunction is true when the components of the conjunction both are true. So false and true, false, false and false, false, true and true, true. False and true, false, true and true, true, true and false, false, false and true, false, and false and true, false. Yes? Let's say true, yes, true, 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 true. Yes. And finally, now, we just solved this, and finally this number 2, and when we are going to solve this conditional, remember that since this was the last column we solved, we are going to compare this as the antecedent and R as the consequent. Now, I'm going to write this this column of the values here, there, in order to state and in order to confirm that we actually got kind of the same values. So for example, we have this column is false, false, true, false, true, and false, false, false. The thing here is that in the next or in the last rewriting or in the last attempt to solve this, remember that we solved first in this first attempt this number 2, and then we solve this one. We are going to change them, okay? But in a moment, let's solve this the truth table first. Now, so as I said, we are going to compare this as the antecedent, and this as the consequent, okay? Consequent. Now, we have number 2 as antecedent, and this is an R as a consequent. Remember that this was the last logical connective that we solved of these brackets, or of this whole expression. So this is going to be, or this was in in this sense, the most the most dominant logical connective in this expression. I'm tired. Okay, I'm really sorry. And then we already have the given values of R. So we're going to compare this with R. Again, if you want to write a column here, an extra column, and rewrite this value of R, be my guest, there is no problem. I'm a web1, so I'm not going to write again. So we have false as antecedent, well, number 2 as antecedent, and R as the consequent. Remember that the rule of the conditional is it is always true except when the antecedent is true and the consequent, that in this case is R, is false. So we have false and true is going to be true. False and false is going to be true. True and true is going to be true. False and false is going to be true. True and true is going to be true. False and false is going to be true. False and true is going to be, yes, false and true is going to be true. And finally, false and false is going to be true. As you can see, this was the last step, so we can say that this is a tautology. Tautology. Woohoo! What is this? What is that? Dun, dun. Okay, tautology. Now, I'm going to rewrite again, and we're going to change, instead of in solving this number 2 first, I'm going to now solve this number 2 first, and then we're going to solve this one, okay? Okay, so finally, we are going to solve we solved in the previous attempt this first one, this first conjunction. Now I'm going to start with this one, and then we're going to move to this one. Now this number 3 actually is not going to change. We have MC, we have MR, we have CR, and these values are not changing, so therefore these columns are remaining as the same, okay? And the only thing that is going to change is the order. Now I'm going to solve first this one, and then I'm going to solve this one, okay? Remember the cartouches stuff, okay? We are going to solve this conjunction between these 3 and these 3, okay? So remember, the conjunction is true when both of its components are true, okay? So we have true and true, we have true, false and false, this is false, true and true, this is true, false and true, this is false, true and true, this is true, true and false, this is false, true and true, this is true, and true, this is true, okay? True. Now, remember, cartuchos stuff. Si ya usaron este, no pueden volver a usarlo, ya es cartucho usado, ¿ok? Por ahora, o más bien en adelante, esta conjunción va a comprender... Oh no, otra vez esa alarma. Sorry, my lovely students. Okay, I'm really sorry. One problem or one issue with the neighbors, okay? I'm really sorry. We already used these two columns, okay? We got this number or this column number 2, okay? Now, if we want to solve this one, cartuchos stuff, si ya usaron estos, no los pueden volver a usar. Now, we are going to solve this one using this number 3 that we haven't used yet, and we are going to use this one, the first conjunction that we solved, in order to get this column. So remember again the conjunction. The conjunction is true when both of its components are true. So false and true, this is false. Wait a moment, please see. Compare this column to those values. False and true, false. False and false, false. True and true, true. True and false, false. True and true, true. True and false, false. False and true, false. False and true, false. As you can see, my lovely students, we have false and false, false and false, true and true, false and false and true, false and false, false and false, and false and false. As you can see, the last column that we get from this expression in the brackets is basically the same as the previous exercise or as the previous example. So in other words, it doesn't matter which conjunction you are going to use first, if this one or this one. Now, what is important is the cartuchos stuff. If you already, for example, we started in this last attempt with these 2, 3. If you already used these 2, 3 or these 2 columns, you cannot use them again. You are going to use this number 3 with this number 2, okay? And now finally again, if this was the this is the primary logical connective. Now the antecedent now is here, antecedent, and the consequent is R. Now, if we got for the most important logical connective in the expression of the left, or yes, of the left, this column, and if that is basically the same as the previous exercise, we can know that, and did R change? No. So that means that we have the same results. True, 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 true. And as you can see, we have the same values again, and we have tautology. That would be all, my lovely students. I promise. I hope that you are okay. Maybe, I don't know. I know that I divided these videos in 3 parts because I know that it could be a lot of information or a lot of practicing, but my lovely students, if you have any doubt, please let me know, and please take care. I really miss you.